Namaskar. Welcome to Prakash on Basics. I'm Prakash Zog, and we've been talking of some of the aspects of radioactivity. It is the ability of human intelligence to correlate different things in nature and make inventions. That's what has led to our topic today, which is radioactive carbon dating. Properties of nature, radioactivity, and keen observations have led to this discovery, whose work originally started off around 1940. Carbon dating is a method to determine the age of very old organic based materials, which were living once upon a time. The method is accurate up to about 50,000 years from now back. Why only up to that much is an aspect that I will mention sometime later on. And the degree of accuracy that we have reached today is that the age can be determined as accurately as plus or minus 30 years. That's pretty good. Um, what is carbon dating? Let's go into the background first. All known life on Earth is carbon based. Uh, it is based on the chemical properties such as catenation and many others, something that I talked of long time ago. Um, Carbon, of course, is the sixth element in our periodic table. It has six protons and six neutrons. Uh, it has a radioactive isotope. When the number of protons remains the same, but the number of neutrons changes, what you get is typically referred to as an isotope. Now, if we have six carbon, rather in carbon, if we have six protons, but more number of neutrons, like say eight, then what you get is total of six plus four, six plus eight, that makes it 14. So this becomes carbon 14. And it is this carbon 14 which is radioactive. Basically, as I talked of radioactivity, it is indistinguishable from normal carbon that we know of. Chemically, it is the same. So for us humans, it absolutely makes no difference at all. It has a half life of 5,730 years. That means in so much amount of time, half the radioactive atoms that were present or half of its activity will reduce to half the original value. And how much material is present? Roughly in the ratio of 99 to 1%. So normal carbon is about 99% and 1% is carbon 14. Where does it come from? For millions and millions of years, Earth has been bombarded by cosmic radiation. It naturally, cosmic radiation is going to affect the outermost layer of atmosphere the greatest. One of the biggest advantages that we know of today is the ozone layer that is created. It also has other effects on other elements. So it also interacts with nitrogen. Nitrogen has seven protons. So what this cosmic radiation does is, because of its energy, one of the neutrons gets knocked off, one of the protons gets knocked off, and it becomes from carbon. It becomes carbon because now the number of protons have reduced to six instead of seven. So nitrogen, which is N 14 7, reduces down to carbon 14 6, and this is radioactive carbon. It immediately reacts with the oxygen that is around and forms CO2. And the CO2 itself, being heavier, gradually starts moving towards Earth, where during photosynthesis it gets absorbed by plants, gets dissolved and it goes into water, and there's a carbon cycle as we talked of long back. And then all living organisms, directly or indirectly, tend to ingest or take in this carbon 14. And this has been going on for millions of years. So, whatever is the ratio of carbon 12 to carbon 14 in atmosphere is the same as that in all human beings, living beings like me, or all the other materials that are there, including this plastic model that is there, or any object that has an organic base. We cannot apply it to plastics. We have to apply it only to things that were living once upon a time. Why? Let's look into that also first. Uh, when do we take in food? As long as we are alive. The instant you die, this food that is being taken in stops. Carbon dioxide that we take in, breathe out, that also stops. So the outgoing has stopped, the incoming has also stopped. So the amount of carbon 14 in our body is fixed. Now, this is radioactive, so it begins to decay. In the process of decay, this decay takes place because of beta radiation that is given out by uh, carbon 14, and then it uh, gradually converts over to what we typically refer to as nitrogen once more. That doesn't take place instantaneously. It depends upon the half-life of the element. So gradually as time passes, the carbon 14 gradually within the organism that was once living starts gradually reducing. Now, because of certain techniques, if we can measure this carbon that is present, we should be carbon 14 that is present, we should be able to find out when this organism was living. In around 1940, uh, work based on this idea was started by a scientist called Libby. And by around 1947, he perfected a method to try and measure the percentage of carbon 14 in our human body, or in living cells, or in dead tissues, and in other areas. So any sample that was once upon a time living was tested, and the ratio of carbon 14 to carbon 12 was determined. Now there are a lot of equations. uh, n0 is equal to, or rather n is equal to n0 into e raised to minus lambda t, which gets modified, and so there are many mathematical equations that were put down for radioactivity. Using one of the forms of this particular equation, you can precisely find out when the carbon 14 within that particular sample was at its original base level, which is the instant when the species died. And this is the time when the species was living, so we can determine the age of that particular object. It could be a piece of wood, because trees also have carbon 14. It could be bones from human body, or it could be dead tissues that were found in various forms, and so forth, in fossils. So using this method, Libby perfected the technique, and in 1960, he was given a Nobel Prize in chemistry for his great discovery. The first thing he did was to test it on some old objects, and that were known to be some mummies of old pharaohs in Egypt. And he determined the age of the mummies and the kings who were there to around 2800 BC. But that time the methods were not very refined, so naturally he was uncertain up to an age of around 250 years plus or minus. Now, of course, the methodology has improved far more, and so very accurately we can determine the age up to plus or minus 30 years. That's not the only place it was used. It was used in many other places. One of the I just mentioned a couple of them. One is associated with what many of you all who are interested in science and other areas would have heard of, known as the Dead Sea Scrolls. There were some documented parchment papers and silk threads made out of silk and other material that were found in the Dead Sea, and there were references to Christianity in it. So they wanted to find out how early these fragments were, and so these were tested, and the age determined was close to about the first century AD or slightly prior to that. And so then they were proved to be one of the oldest documents of Christianity that were found. Uh, there's also a very strange story. Uh, there was said to be a piece of cloth which had a imprint of the outline uh, of Jesus, and it was believed that it was used at the time when he was actually crucified, and it had contained samples of the blood of Jesus himself. Uh, and this was tested by 4 or 5 different laboratories by using this particular technique, and it was finally proved that this sample was around the 13th century and not as old as it was claimed. So there are many areas in which this was used. Actually, see, all on Earth, we know that many geological changes have affected biological systems and caused a change there also. To find out when the ice age in particular areas actually disappeared was also tested by using this particular method. So, when was the last ice age? That was also determined. When was the end of the Bronze Age? That was determined. When was the end of the Neolithic age? That was also determined by these techniques. So this became a very important technique for determining age. But I told you that it was restricted to about 50,000 years only. The reason is very simple, actually. Remember what I talked of when I told you what half-life is? Half-life tells you the time in which the number of atoms reduces to half the original. Now, as it is, carbon 14 is 1% in the total amount of carbon that is present within the body. And in 5,730 years, the number is going to reduce to half. So the ratio is going to be 99.5 to half a percent. And every successive 5,790 years, it is going to become half, 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 half. That's powers of 2. So half, 1/4, 1/8, 1/16, 1/32, 1 upon 64, 1 upon 128, 1 upon 256, 1 upon 512, 1 upon 1028, 1 upon 10, 20, 48, and so forth. So that's around 10 half-lives. And so in about 50,000 years, the percentage is going to become 1 upon 2000 times the percentage of 1%. So the accuracy of measurement is going to reduce. And so the amount of error that is going to occur is going to be quite high. And so it may not be possible to use this particular technique to determine the age of things that were older than 50 to 60,000 years. As it is, with time, technology will keep on improving and this range will start going more and more back, and we will be able to measure things better. But that's not the only problem with this technique, though it is extremely beautiful. There are 2 or 3 issues that come to the forefront. The first is that the percentage of carbon 14 to carbon 12 has changed because of a variety of reasons over time. And that change means that if you take a particular value, it may not be accurate at the time when this particular object was living. So there could be an error. So special calibration curves were made and designed to use this. After around 1945, a lot of nuclear tests were carried out, and big blasts reaching about 20 million degrees were created by while testing, and that created a lot of cosmic radiation, which resulted into a drastic increase in the percentage of carbon 12 that was around. It is believed that by around 1965, and the nuclear testing had resulted into practically doubling of the ratio of carbon 14 in atmosphere. So naturally there is going to be an error. So, and after that, gradually, of course, the testing processes have stopped, so things have started coming back to normal. But there are other reasons why radiation is not really very consistent, so there could be errors. This is a second factor. uh, Deep down, when fish are present, the ratio of carbon 14 that is tested within them could be different. And if they consume something that is very old, and its carbon 14 ratio is different, then naturally it is going to affect the system itself. If by chance a sample is close to another radioactive material somewhere in the deposits, then that is going to change the percentage of carbon 14 within the system also. So there are some errors of this sort that could occur, and because of this, other techniques are also used to determine the age of objects. We can't use it for fossil fuel, which we typically know of to be made out of organic material, because its age goes down to millions of years ago. And by the time you try and calculate those, the materials the, will have so low percentage of carbon 14 that it will be beyond our detection abilities at present. So you cannot really apply this technique to more than 50,000 years ago. But up to that point, the method is extremely good and extremely powerful to determine the exact age. I've been talking of a lot of complicated things. Well, why not make a little simple and try to understand how can you do that really? So let me simplify things and bring down before I conclude on this topic. Let's try and simplify things. As I told you, the original equation is n is equal to n0 into e raised to minus lambda t, and it gets modified in terms of natural logs and log to the base 10, and it gives you a particular equation which can be corrected for the calibration curve for C14. That's the complicated part in maths. But let's not go into that detail. Let's try and simplify things. Okay, let us say that the half-life is not that 5,730 years, but simple number 6,000 years. So let's say the half-life of carbon 14 is 6,000 years, and half-life is so much. And let us say I have uh, the ratio is 99 is to 1, and it could vary to a small extent depending upon the calibration curve pattern, etc. Let's take a simple number. Let us say I have 10,000 atoms and 16 atoms of carbon 14. Technically I must talk of so many billion, otherwise I will not be able to apply statistical methods, something that I told you some time back. But let's simplify things. So I have 10,000 and 16. Now the half-life is 6,000 years. So after 6,000 years, out of that 16, 8 will get converted to nitrogen and disappear out. So the ratio now becomes 10,000 is to 8. So after another 6,000 years, that means total of 12,000 years, the number will change to, from 8 it will become half again, that means it will become 4. After another 6,000 years, that means in total 18,000 years ago, the ratio, if the sample is from that time, the ratio that will be measured will become half of 4, that is 2 is to 10,000. So now if I pull out a particular sample, and in that the ratio is 10,000 is to 1, 1 is half of 2 again, which implies that another 6,000 years must have gone by. So a total of 4 half-lives must have gone by. And that obviously means that there would be a total time span of 24,000 years ago when this particular sample of wood or bone or fossil material was alive. Every time the ratio is not going to remain 8, 4, 2, 1, etc. It will be intermediate. But for intermediate ones, there are other technical calculations that are available. And so an exact determination of the age of the sample can be carried out. So uh, this is the technique which is known as carbon dating. There are other techniques also. Uh, Dendrochronology, that means measuring the rings within the section of plants, trees, very old trees, and then uh, potassium 40, K40 is used, and so forth. But those are a little more complex and complicated techniques. Uh, if time permits, sometime I will talk about them. This then is what we know as carbon dating. It's a very popular concept in science, a very important one. And so at least what it is must be understood by us. There are other things that are equally important in radioactivity, like how the nuclear or radioactivity use based nuclear power plants work and other areas. We'll talk of them also. If you liked whatever I have said, please like and subscribe to this channel. Um, Appreciate the beauty of how human intelligence uses many of the things in nature to for its own advantage in this manner. Uh, we'll be talking of some more things in radioactivity sometime. Till we meet again, Namaskar.